What is the final temperature when 3 kilogram gold bar at 99 degrees Celsius is dropped into 0.22 kilograms of water at 25 degrees Celsius? So, first of all, you need to identify the two substances. This is pretty obvious. We're talking about a gold bar and we're talking about water. So those are the two substances that are involved here in this problem. Now what I do is I organize my data separately. I have my water and I have my gold bar. Okay, those are the two substances. Now, there's another thing that I do, and it's well, yeah, I separate my givens. But there's another thing that I do is that I tell which object absorbs and which one releases. That's the most important step. Now, take a look. In calorimetry problems, water is always absorbing energy. Okay, so water is going to be always the substance that absorbs. And then the other substance is the one that is going to be releasing. Okay. Now, absorbs is also known as gain. Okay. Absorbs slash gain and release or loss. That's the most important step, determining what substance absorbs or gains energy and which one releases it. Now, because we have two substances, you know that the formula that we must use is this one. Q gained equals negative Q released. That's the most important step. Because from the equation, from the formula, you can determine what are the givens that you need. So you know that Q gain is, in this case, is water. So this is Q of water. It's going to be negative Q of the gold in this case. All I did was an arrangement changing gain by the substance that gains and releases by the substance that releases. And I just plug in the data that I need the mass of water times the Cp of the water times delta T of the water equals to the negative the mass of the gold bar times Cp of the gold bar times delta T of the gold. So that's all I need. So I start by writing the data. I have water, a mass of 0.22 kilograms of water. About the gold bar, I know I have a mass of 3 kilograms. Remember, always check the units. We have kilograms and kilograms, so with me it means that we don't need to do a conversion. But if it is in grams, you have to do the conversion to kilograms, by dividing the given by 1,000. Then we have the Cp. Even if it's not given in the problem, Cp of water is 4,186 joules over kilogram Celsius. And the Cp of gold, you look for it in the table. I'm gonna look for the table. I have the table here. Let me look for it. I think it was 129 or 128, something like that. I'm bringing it, sorry. Okay. So according to the table, the specific heat capacity for gold is 1.29 times 10 to the second power, or 129. It's the same. Now, what else I have? I know I have the initial temperature of both substances. I have the initial temperature of my water to be 25 Celsius and the initial temperature of the gold bar to be 99 degrees Celsius. And then it's asking you, what is the final temperature? So for this kind of exercises, when we have a final temperature, means final temperature for both substances. So my final temperature is unknown and it's common for both substances, okay? So from this, you can start working on the problem. Just remember, final temperature in calorimetry is going to be the same for both substances. So we're talking about the same variable. So what do we do after? So we start working, we start with the givens. Okay, so I continue with my mass of the water, that is 0.22 kilograms, times Cp of water, that is 4,186 joules over kilogram Celsius, and here, times delta T. Delta T, remember, is final minus initial. Here we're talking about water. And all this is equal to whatever you have in the other side. We start by the negative. You don't forget the negative. I always forget the negative, but please you don't. If you forget the negative, the answer is going to be incorrect. So trust me, don't forget the negative here. Put it a mark so you don't forget. No, it's playing in the bed. Anyway, now what I have in the other side of the equation, I have the mass of the gold bar, that is 3 kilograms. I have Cp of the gold, that is 129 joules over kilogram Celsius. And all this is also multiplying times delta T. In this case, delta T is final minus the initial temperature, but in this case, of the gold bar. So what I do after is I multiply, okay? How much do you get by multiplying 0.22 times 4,186?
I got 920.92.
Okay, so here is 920.92. Here you need to cancel some units, like for example, kilograms with kilograms. So the final units are going to be Joule over Celsius. And all this is being multiplied times Tf minus initial temperature of the water, that is 25 degrees Celsius. All this is equal to whatever you have in the other side. Don't forget the negative. Now here I will multiply 3 times 129.
387.
387. And here again, I see if I can eliminate of some units, get rid of some units, the kilograms and kilograms. So this is going to be in joules over Celsius. And again, this will be multiplying TF minus the initial temperature of the gold bar that is 99 Celsius. Now, take a look. This is all you have so far, okay? So what I do is I pretend I don't have units, okay? I pretend I don't have units. And here I see that I can apply distributive property like that. And also, in the other side of the equation, I can apply distributive property. So this is going to give me 920 0.92, that is multiplying TF. Then I copy this symbol, negative, and then 920 0.92 multiplies 25 gives me 23,023. Okay. Now, in the other side of the equation, I have negative 387 times TF. This gives me negative 387 TF. And then 387 multiplied times 29 gives me, and take a look here. Remember, here you have the negative, and you are multiplying negative times negative. Here it's going to make a positive. Positive, the result is 38,313. And what happens, as you can see, I have the same variable in two sides of the equation. So what comes after is that you need to put the variables in a single side. So I'm going to move this one that is making a subtraction. I'm going to move it to the other side of the equation by making addition. So I'm going to have 920.92 TF plus 387 TF minus 23 equals 38,313. And again, I repeat, I have TF, the same variable. So when you have the same variable, what you have is the common factor thing. Now you can just add 920 with 387. Which gives me 1,307.92 TF minus 23,023 equals 38,313. Now I'm just going to move this one that is making a subtraction. I'm going to move it to the other side of the. So the 23,000 that is subtracting, you're going to move it to the other side of the equation by making an addition. So you want to have in the end, you're going to have 1,307.92 TF equals 38,313 plus 23,023. How much is this?
61,333.
61,336. Okay? And now, remember the purpose is to isolate TF. So all this number is multiplying TF. Okay? There is doing multiplication. So when you move it to the other side, we'll be doing a division. So you will have TF alone equals 61,336 divided by 1,307.92. How much is this?
46.89.
46.895. 896, sorry. So in the end, this is going to be rounded to 90, okay? Because 6 is going to give 1 to 89, so it's going to become 90. And voila. With this, you have your final answer. Now, this procedure it looks a little longer, but remember, I'm explaining the procedure step by step. I'm explaining the procedure step by step, and that's why it takes long. But in the end, I think you can do this exercise in 15 minutes. Now, was it impossible to solve? It wasn't. It wasn't. Do you have a doubt in any of the steps? Let me know.
I have a doubt, Miss.
Yes, tell me.
In how I can tell you, in the Celsius 25 Celsius, how do you get it into a number that is 23,023?
Remember distributive property here. Okay. I'm gonna put this number a little bit together. This number multiplies TF, but also multiplies the 25. So when you multiply 920.92 times 25, it gives you 23,023. Did you get it now?
Yes, Miss. Thank you.
Remember that I had a space between the number and the parentheses because I used to have the units there. But I'll take the units away because I'm about to make this distributive property. So I think it looks more organized if I just take it away. Just remember distributive property, like we used to do in math. If I have 2 that is multiplying x plus 1, apply distributive property, you will have 2x plus 2. Okay? You're doing the same procedure here, but instead of using x and 1 and 2, you're using different numbers and different variables. Instead of x, you have a TF.